right? Okay. So anybody who is there from humanity background, an arts background, commerce background, they should also understand this. Okay. Now let's move on. Now let's get back to the cell structure, and you can see like entire story around the cell is related to protein. Like I told you that nucleus is control room, it has got DNA. This DNA give command to the ribosome. Ribosome is a protein synthetic mechanism. It's a worker which can make protein, and this worker will make protein, and protein will be stored in the Golgi body because it's all moving around protein. Right. Biocatalyst means enzyme. For chemical reaction, we need catalyst. For biochemical reaction, we need biocatalyst. Catalysts are those which can increase the rate of reaction. Right. Right. Yes, yes, vesicles and all, we won't enter into that. Now let's talk about one structure that is called nucleus. So we'll focus on nucleus. Nucleus is very interesting because nucleus has got DNA. So we are leaving cell behind and we'll talk about nucleus. And if I make one structure of nucleus here, so this is how nucleus look like. A nucleus will look like this. A nucleus will look like this. You got it? And this is how the nucleus will look like. And inside nucleus, you will have entangled thread-like structure. There would be one round structure, denser one. And there will be a liquid present inside. Liquid present inside. Right. This structure is of nucleus. Right. Right. Now, this is your nuclear membrane. Like we have plasma membrane. So this is your nuclear membrane. What we call it? Nuclear membrane. Right? This structure is called nucleolus. Nucleolus. Not important at all, just nucleolus. This liquid part is known as nucleoplasm. Nucleoplasm. That is also not that important. But this part, this entangled thread-like structure, this is the most important part, and these are called chromatin. What we call it? Chromatin material. Chromatin material. Now somebody can say that how come this is chromatin? Because we talked about DNA. Yes. But here this entangled thread-like structure is called chromatin. But you look into chromatin. Once you get inside the chromatin, then you will realize that this chromatin is made up of two things, DNA and histone protein. Which protein? Histone protein. Remember, everything in our body is made up of protein. So even this chromatin material is also made up of protein. So there are two parts of it. One is DNA and then histone protein. This is chromatin material. It's an entangled thread-like structure, and this entangled thread-like structure has a very unique character, right? It's a thread-like structure. But imagine, okay, how many of you fly kites? How many of you have experience of flying kite? Kite flying. How many of you have done kite flying? Okay. 15th of August, you might have. Okay. Amit, Antar, Soumya, Mahi, Okay, so when you fly kite, then you use a special thread, and the thread has got manja. I'm sure that you know manja, right? Sheetal is also there in kite flying team. So I'm sure that all people who are flying kite and those people who are not interested in flying kite, they know that thread is not alone. The thread is covered with manja. Manja is there, right? So similar kind of thing is there. DNA is thread, and on that thread, histone protein is there as manja. Now, what is the function of manja? Manja can do what? Manja is something which will make the thread stable and stronger, right? So manja is something which will make thread stable and stronger, so that you can, you can fly it properly. You can cut the other thread. Similarly, in this chromatin material, DNA is like thread, and there is a protective layer that is called manja. So DNA here we can write DNA is genetic material. Genetic material. Why? Because it has got genetic code. It has got all the information in our body. Right. Why we call it genetic material? Because it holds genetic information. Holds genetic information. Right? It holds genetic information. And histone is non-genetic material. What is that? Non-genetic material. It's just a protein. And protein can never be genetic material. It's just along with the DNA, but not genetic material. But why this histone is there? Histone is there to make DNA stronger. Stability to DNA. So it is for stability to DNA. That is for protection of the DNA. You know that? Now, I'm sure that everybody know about this particular DNA as genetic material. Like we get our DNA from our parents. In my body, half of the DNA came from my mother and half of the DNA came from my father. And when the DNA is coming for father and mother together, then that is what I am. Some of my feature resembles with my mother, some of my features resembles with my father, and then I got the unique personality of mine. Every one of us is unique in a way. Like Sheetal is unique, Soumya is unique, Ritesh is unique. Ritesh, अरे Ritesh मैं भी, Ritesh आप भी. Hello Ritesh. Anyway, Matri is unique, Pratiksha is unique. We all of us are unique. Why we are unique? Because we got the genetic material from our parent. We got the DNA from our parent. And whatever body character we have in our body, like hair texture, curly hair, straight hair, blue eye, black eye, lips structure, skin texture, skin color, body organs, this all kind of thing that we have in our body, even inside the body, that is determined by the DNA. Because DNA has got all the genetic information. And we get this genetic information from the previous generation. So DNA is very important, right? And then histone protein is always there with the DNA so that it can stabilize the DNA. Got the point? ठीक है? तो ध्यान ये देना that DNA is not alone. In nucleus, DNA is always like having chromatin material like a structure. You got the point? Okay, fine. Now, we'll focus on some terms because we are clearing basic concepts. So we are going to focus on some more terms, right? So there is something here we can sum up. So there is something called chromatin material, and that is present in nucleus. And what is chromatin material? It has got DNA and histone both, isn't it? But then, normally, whenever we talk about nucleus and cell, then we talk about DNA. So when we say DNA, only DNA. So DNA is what? Deoxyribonucleic acid. We'll talk about that. It's a genetic material, right? Thread-like structure and genetic material. In the cell, in the nucleus. In the nucleus. Right? Right. Thread-like structure and genetic material in the nucleus. Okay? So that is thread-like structure. Right. But then there is something called gene. Are you aware of this? Gene. Right. Okay. Gene. Gene is a very common term. Gene is a very common term. Very, very common term. So gene is nothing. Let's say if I can tell you here, let's say this is thread-like a structure and this is a DNA, right? This is DNA. So this thread-like a structure is DNA from point A to point B. So point A to point B, let's forget about the point. There is nothing like point. It's just like DNA is thread-like a structure. And you know that a segment of this DNA, I can show this segment like this. Let's say I'm making a segment. A segment of this DNA, I'm making this segment, let's say. This segment of the DNA is called gene. So this is your gene. And there could be many segments. It's not like one segment. There could be many, many segments. What is that? Gene. Right. So DNA is thread-like a structure and gene is a part of it. Like I'll tell you, sometime you go and buy the thread. Okay? Many a time your parents will tell you to go to the market and buy a thread. And then there are something called designer thread. In designer thread, the color of the thread will change after intervals. So it's like, long thread. I'm holding a thread from here to here. Can you see this thread? You cannot because there is no thread. But imagine I'm holding a thread. I'm holding a thread like this. You get the point? So this one end and other end. This entire thread is DNA. Yes, this DNA is having histone protein on it. But for understanding, we have removed the histone protein. No histone protein is there. It's just like thread only. You get the point? Right? And then this thread-like structure is designer thread. So after every few inches, the color would change. Red, green, blue, black, white. So these are the different color segments. All these color segments are genes, right? So assume that entire thread is DNA and the different color segments are genes. I am showing just one color segment, but different color segments are gene. So what are genes? How can we define genes? So genes are segments of DNA. So how many segments it can have? Many, thousands of segments would be there. A structure का short form, STR structure, right? So gene is segments of DNA. Got it? Segments of DNA, nothing else. So now you know chromatin material present in nucleus. Chromatin material has got DNA plus histone. Here, DNA plus histone. DNA plus histone. But histone has got just one function, to stabilize, to make the DNA stable and secure. You know, DNA is like your mark sheet and certificate. right? So DNA in our body is like mark sheet and certificates. In our academics, once we pass 10th class, 12th class, graduation, we get mark sheet and certificate. And you know that our mark sheet and certificates are unique. No two persons' mark sheet can resemble with each other. It can never be same. Similarly, DNA can never be same. My DNA is unique and nobody else in this entire world will have the same DNA as I am having. Gargi is having her own DNA and nobody in this entire universe will have the DNA that is similar to carbon copy of the Gargi's DNA. Like nobody can have the same mark sheet and same certificate. Every mark sheet and certificate is unique. Subjects are changed, marks are changed, names are changed, father name is changed, DOB is changed. At least few things will be changed. But to secure our mark sheet, we do lamination onto the mark sheet. Lamination on the mark sheet. And lamination is what? Plastic. Everybody has got same lamination. I have lamination on my mark sheet. You have got lamination on your mark sheet. So my mark sheet and your mark sheet is same, isn't it? It's the same mark sheet. No, my mark sheet and your mark sheet is not same, right? My lamination and your lamination is same. Mark sheet is different. Similarly, DNA is different, that is by genetic material, but lamination is same. Histone protein in my body, histone protein in your body, that's same. Histone proteins are same. It can never ever be same. Got the point? And obviously, when you have laminated mark sheet, once you have laminated mark sheet and you apply for a job, then examiner are basically looking into your mark sheet. They get impressed by the data that is written onto your mark sheet. They never get impressed by the lamination. They won't say that, oh my God, what a kind of lamination, what a nice lamination. Let's give this job to Omeshwar because Omeshwar has got such a nice lamination. No. Omeshwar will get job because Omeshwar will have so many good data and good marks and good division in the mark sheet. Got the point? So whatever written onto the DNA, that's genetic data. Got the point? And that is important one. But lamination is a stone. Everybody will have the same lamination. And it will not hold any data. It is just to stabilize and secure the DNA. So that is why it is non-genetic. Now what we do, that for understanding, we remove histone. Mentally we remove histone and we just talk about DNA. Why to talk about lamination? Why to talk about lamination? If I have to talk about your academic characters, then we'll talk about the marks and mark sheets and certificates. I won't talk about lamination at all. So that is why whenever we talk about genetics and biotechnology, we never talk about chromatin material. What we talk about is DNA. And then we say DNA is a thread-like structure. And then we forget about the histone protein mentally. But DNA from this end to this end, this DNA from one end to the other end. You get the point? From this end to that end, the DNA is not just one piece. There are different segments of it. And each segment of the DNA is known as genes. I'll tell you one thing. In human body, there are 30,000 genes. How many genes are there? 30,000. It means that this DNA is an entire thread-like structure and this DNA will have a small segments one after other, and these small segments are known as genes. You get the point? So genes are what? Segments of the DNA. Any problem with that? But then there is another term and we call it chromosome. What we call it? Chromosome. Now what is chromosome? What is chromosome? Right. Let's get back to the analogy of thread. Like I told you, I have got a thread and that is a designer thread. I'm holding the thread from one end to the other end. This entire thread is DNA. Right? The entire thread is DNA. But this designer thread has got a very unique feature that after every few inches the color is changing and all the color bands and segments are genes. So this is thread, and this thread has got color bands. These are the genes. But when you go and buy the thread, let's say you are going in the market to buy the thread. Thread will not be given in an open condition. The thread will be given in the reel condition, coiled reel like a structure, very nicely packed reel like a structure you will get. And then this reel you will use it. Similarly, what happens? DNA is a thread like a structure, but when the cell is going to divide, this DNA will coil. And the coiled structure of DNA is known as chromosome. What we call it? Chromosome. So this DNA will coil. When this DNA will coil? So here I am saying coiling of DNA with histone. With histone. Histone is what? Protein. The histone is always there. Coiling of DNA with histone. I'm writing again. Let me write it again. So here what is happening? Coiling of DNA with histone. What is histone? Histone is protein. So how it is going to coil? I'll tell you. Just look at this. It will coil like this. This kind of coiling is spring. It will again coil like this. It will coil like this. Very dense coiling. And ultimately it will coil like this. So DNA has coiled very densely. This is coiled like this. Right? And obviously, what about this gene? This gene is an open DNA. In open DNA look like this. But the same gene over here, if the coiling is occurring, this might look like here. ये यहाँ है. And then it might look like here. It might look like here. And here it will look like a dot. Isn't it? So that is a segment. This segment is here. Coiling is even more. So this segment is condensed, more condensed, and appear like a point. So this is your chromosome. With this structure is your chromosome. Chromosome. And this structure here, this is your gene. This structure is gene. I am showing just one gene. Now you can relate with that. You have to draw it. Obviously, it's very easy for those who are from science background. But believe me, on a lighter note, I must say that I'm not bothered about you today. Today, my commitment is with non-science student. Amit will come to that. Okay, so let's talk about it. So chromosome is what? Chromosome, DNA plus histone protein, coiled structure, and it is chromosome. So here we can write chromosome is DNA plus histone, then coiled structure, coiled structure. It is coiled structure, right? Coiled structure. And then we can write visible only during cell division. So when the cell is going to divide, then only you can see the chromosome. Otherwise, you never see the chromosome. Otherwise, you see the chromatin material present in nucleus in normal time. Right. So present in nucleus in general time, in general. Right. And then if you remove the histone mentally, then DNA, a part of segment of the DNA is known as gene, and this is chromosome. Right. And you know that genes are very common terminology these days. Genes are now being used in literature. Right. Sometime what happens that when we talk about something, and if I say that my hair is good, right? I am 46-year-old, and obviously for 46-year-old, the hair is good enough. So I always say that I get the gene from my mother. My mother hair is good. I got the gene from there. My father has very less hair. Thank God the gene is not from my father. The gene is from my mother. So it's so easy to use gene in a daily life also, right? If somebody is having blue eye, and if father is having blue eye, then the person would say that, okay, I got the gene from my father, that is why my eye is blue, right? So many a time we use the gene word scientifically and non-scientifically. When we use the word scientifically, then we say that, okay, I got the genes for hair from my mother. So my mother hair is good, my hair is still good. For the 46-year-old people, it's good. If your eye is blue and if your father eye is blue, then you say that, okay, I got the gene from my father. Good enough, right? But if somebody is singing very well, somebody is singing very good, if any of you are singer, and even your mother is a very good singer, and then you say that I got the gene from my mother, that is why I'm singing well, that's not true. That's not science. That's not genetics. That's not gene. That is conditioning. That is learning. You get my point? So there are two types of character. One is called genetic character. Genetic character are those which will come through the gene, like our skin color, our lips structure, our eye color, our eye structure, our hair texture, our hair color, our body characters. These all are genetic characters. But then there are certain things which are called acquired character. Acquired character is what? We acquire it, we learn it. We get it from the surrounding. Somebody is very good singer, somebody is very good orator, somebody can play instrument very well. So these all will learn. Intelligence will never come as genetics. It's not like that father is intelligent and mother is intelligent, then kids will also be intelligent. No, nothing like that. Yes, father and mother both are intelligent, then the kids would be having intelligent exposure. So the kid might become intelligent. Right. So in my body, in son's body, genes from father and mother, both side will come. In daughters also, the genes from father and mother, both side will come. Right. So genes we get. दोनों पेरेंट्स से आते हैं. अनुराधा, we always get gene from both the parent. We can never get genes only from one parent. Okay. So gene is something that we use it in a very literal sense. So let's say, I'll explain it once again. If your eye is blue and your father eye is blue, then you got the gene from father. But if father is a doctor and then the daughter or son is also a doctor, then it's not gene. It may be the talented It may be the talent or corruption, right? You get my point? But it is never genetic. If father is IAS and the son and daughter is IAS, it's hard work and talent. It's not like gene. You get my point? But gene are something which is called unit of inheritance. What is inheritance? Inheritance means if you get something from father or mother, that is called inheritance. Anything that you get from the previous generation is called inheritance. Like your father and mother is having a house, then you will inherit this house. That means after father and mother, this house will belongs to you. This house will belong to you, right? Got the point? So inherit means that you get it from the previous generation. And inheritance is also a word that is being used in biology and biotechnology and in general life also. Let's say your parents are having money in the account. So that money in the account will be inherited by you one day. All the saving of the father and mother will be inherited by you. You will inherit it. Similarly, genes are the mean by which we inherit the character. If I get father character, then I got inheritance from my father, right? So you can write genes are unit of inheritance. 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 Next point you can write. Genes carry information. Genes carry information. Genes carry information or genetic character from genetic character from one generation to next generation. Genes carry information or genetic character from one generation to next generation. One generation to next generation. Right? One generation to next generation. So gene will carry information. What I look like is according to the genes that I got from my father and mother. What Soumya look like is according to the genes that Soumya has got from father and mother. What Shraddha look like is the genes that Shraddha has got from father and mother. Right? Next you can write. Normally, one gene determines one character. Normally, one gene determines one character. Normally, one gene determines one character. But sometime, a single character can be determined by more than one gene. More than one gene. And this is known as polygenic effect. Polygenic effect. What we call it? Polygenic effect. Example, skin color. Skin color. So skin color is not determined by just one gene. That is why we see variation in skin color. We do see different variation in skin color. Why do we see variation in skin color? Because when we talk about the skin color, it's not just one gene. There are 4 to 8 genes coming from both father and mother. And when the gene combine in our body, then mixed impact or effect of this gene will come up. That is why we see a lot of variation in skin color. If we are 2, 3 brother and sisters, then all brother sister will have different type of skin color. Different type of skin color, isn't that? Because obviously the gene combination can change, right? I mean, if I give one example, like you know that people at equator, original inhabitant at equator, native people of equator are black in color. They are darker in complexion. And the people in Norway and Iceland and Europe, they are fairer in complexion, right? So if a darker complexion people from equator marry a fairer complexion person from Europe, then offspring, then the kid will not be zebra, right? Kid will not be zebra. It won't be like black and white stripes are there and patches are there, like, you know, it won't be like that. Rather, the color of the kid would be somewhere in between. The kid will look like pretty much like Obama, US president, former US president. Not white, not dark, somewhere in between. They are called mulattoes, right? Because the gene from white father and dark mother and vice versa, with both will combine together and both effect will come up. But it won't be like, you know, stripes on through the body. It will have the mixed color, right? So that is how the skin color. Okay. Okay, one more point we can see. The same gene is a segment of DNA and the same gene is present on the DNA, chromosome, right? So if we have to define gene, so can we call it genes are segment of DNA? Genes are segment of DNA, is it okay? And here at the same time we can call it genes are located on the chromosome. Same thing, so you can write genes are segment of the DNA. Genes are segment of the DNA. Genes are segments of the DNA and genes are located on the chromosome. Genes are located on the chromosome. It's the same thing. If you look at this part, genes are segment of the DNA. If you look at this part, genes are located on the chromosome. Both statements are true, right? Both statements are true. Genes are segment of the DNA and genes are located on the chromosome. It's same, right? And obviously, when the cell is dividing its reproduction, because a sperm will form by cell division, ovum will form by cell division, and then reproduction will occur. So in a most basic term, this cell division is reproduction. And when the cell is dividing, then chromosome formation will take place. And who will carry this gene? Chromosome will carry the gene to the next generation. So we all got genes from our father and mother. But when we were getting this gene through cell division, the gene was riding onto the chromosome. So chromosome is like a bus. On that bus, genes are sitting. So chromosome is vehicle and genes are the passenger. So who is carrying the gene from one generation to the next generation? Genes are being carried by chromosome. Genes will carry character, but gene will be carried by chromosome. So you can write genes are carried by chromosome. Genes are carried by chromosome from from one generation to next generation. One generation to next generation. Got the point? So that is carried by chromosome. Okay, Akku is asking one question, I would take that. Sir, can a child inherit voice quality such like a good singer and memory capacity from the parent? Not at all. Not at all. Voice quality you train yourself, right? It's about riyaj. My daughter, she is into vocals and she is learning vocal. Nobody in my family sing. Nobody in my family is a good singer. But my daughter is singing good enough. Why? Because she is getting trained for the vocals. Training. Similarly, memory capacity training. Soumya has asked, sir, what about memory and a span of attention a child gets? Not about genes. It again not about genes. Not at all genes. Right? These all are acquired character. You more focus, more memory. As simple as this. Right? Somebody asked that why sometimes we resemble more with the father and sometimes more with the mother. It's all depend upon quality of gene that we get. Some gene may be strong. If the genes from father's side is just stronger, then that will show up in my body. If the gene from mother's side is stronger, that will show up in my body. Right? So the stronger genes, that is called dominant gene. So if eye color gene is coming from father and mother both, then only one gene will express. It won't like that one eye is like father, another eye is like mother. No. Both eye will be like either father or mother, depending upon who has contributed dominant gene. So genes may be dominant. Two genes are not at equal power. Either father's gene is powerful or mother genes are powerful. Yes, some gene from father would be more powerful, some gene from father will be more powerful. And then all powerful combination will make, right, our body, right? So that is about your right. Okay. So now let's get back to the cell. वापस cell पे आते हैं. This is cell. And like I told you in the cell, that cell has got DNA in the nucleus, and DNA is genetic material which has got many genes, and genes are holding information. Genes are holding information because, like I told you, that our body characters are made up of proteins. And who is making protein? Ribosome is making protein. But ribosome is making protein with the help of messenger RNA. And who is sending messenger RNA? DNA is sending messenger RNA. So what is happening? If all our body characters are made up of protein, then here we need to understand one thing. Here we need to understand one thing, that we have got DNA. This is what the DNA is. And DNA give information to messenger RNA. What is that? Messenger RNA. And this RNA give information to ribosome, and ribosome will make what? It will make protein. It will make protein. So DNA to RNA, RNA to protein, right? And this protein, right? अच्छा, उससे पहले मैं just I'll show you one diagram so that you can understand it all. Yes, let me show one diagram from the internet so that you can have a very nice concept. Let me take one. Okay, just look at this diagram. I'll come in 1 minute. Okay, I'll show you now. So I'll show you one of the best that you can get. Right. Okay, let's not get into this. I'll just cut the diagram from here. Can you see this? Yes, DNA will store data. Behavior of child is not through genes. Behavior is acquired character. Right. So look at this. This is DNA structure and a segment of DNA is known as gene. Can you see this? So this is DNA structure, DNA double helical DNA, we'll talk about that. A segment of DNA is known as gene. Gene with histone protein, forget about all these things. I'm erasing the rest of the thing that is here for your understanding. I don't want you to have unnecessary, attention. I don't want this unnecessary attention. This is for biology student. Just focus on what is there. So obviously we'll talk about that base pairs, don't worry about it. So this is DNA, a segment of DNA is known as gene, that is gene, here is gene. This is histone and along with histone, what it forms is chromatin and the chromatin will condense to form chromosome, right? Right? Or I can get one more thing. There was one diagram, I'm not getting this point. And that diagram was good enough. Okay, give me just 1 minute. I'll get that. I want the easy one, right? Okay, this is good one. We can get this one too for your understanding. Can you see this? So this is DNA. This is double helix DNA. And a segment of DNA would be known as gene. And then this gene with histone protein, this is histone, it will make chromatin fiber. And then chromatin fiber will condense together to form a chromosome. Right? Is it okay? So two diagram I have given you. You will get this diagram with this class only. Here the same thing is there. This is your DNA. This is your DNA. That entire is DNA only. A segment of DNA is known as gene. Along with histone protein, then it makes chromatin, right? And chromatin condense to form chromosome. Chromosome is there inside the nucleus. Okay? And now we are coming back to the same thing here. And like I told you, the DNA has got the data or information. This information is passed on to the mRNA, messenger RNA. Messenger RNA will take it to the ribosome and ribosome will make protein. Ribosome will make protein. Who will make protein? Ribosome will make protein. And this protein, additionally, I am adding over here, This protein is basically your body structure, and body function. Body function. Why? Because enzymes are made up of proteins. Got the point? This is a very linear learning that you have to understand. DNA to messenger RNA to protein. Now you remember, where is DNA? So DNA is at nucleus. So DNA is at nucleus. It is at nucleus. Messenger RNA, it will come out of the nucleus. It will come in cytoplasm. That means in cytoplasm. In cytoplasm, it will carry the information. And who will make the protein? Ribosome. Ribosome. So nucleus and this messenger RNA, let me tell you, this messenger RNA will travel from nucleus to cytoplasm. So here, nucleus to cytoplasm, right? Nucleus to cytoplasm. And then in cytoplasm, it will give information to ribosome. It simply means one thing, that DNA has got some information written onto it. Yes, DNA has got some information written onto it. How this information are written? So you might have understood by this, you must be knowing about it. The DNA is like double helix structure. It's like this structure, isn't it? DNA is like this structure. Right? And this structure will hold some information. This structure might be looking like a twisted staircase. This is twisted staircase, isn't it? I'll show you that what exactly this structure look like. So this is what I have made. This is DNA, right? Now I'll take one structure of the DNA from the internet also. DNA double helix structure, and I'll get this structure, the easiest one. So bear with me. I'll get that the required one. Okay. I want to get it with the base pair. Okay, I got this. This is how the DNA look like. Okay, fine. We got this. Forget about everything, but here, whatever I'll tell you, need to understand. So what I made over here, this is your DNA structure, right? What I have made over here, if I could cut it further, you can see. So DNA is made up of many different chemicals. We are not getting into chemicals, right? But DNA is holding this information. These are AGCT, adenine, guanine, cytosine, thymine, right? I'll tell you, right? Let's delete it right now. So DNA is this kind of a structure. This DNA will pass on the information to RNA. RNA is a single structure. So this is copy of the RNA. This is RNA. And RNA will be there to make what? It will make protein. And protein structure could be like anything. It's a protein structure. So now this is what? Protein structure. Protein. This is RNA. And this is DNA. First of all, you need to understand it. Right? Now, one more thing you need to understand. The process by which DNA make RNA is known as transcription. What we call it? Transcription. And the process by which messenger RNA make protein is called translation. Translation. So these two words should be there. So this is your transcription. Transcription. And this is your translation. It's simple like the DNA is giving all the information to RNA and RNA is carrying this information to ribosome to make protein. Right? So first of all, you draw it. Then I'll take it to the next thing. Okay, I'll come to that. So you understand whatever there in the DNA, that information will determine that which kind of protein that we are making. Now, let's get into that how this DNA is holding information. How this DNA is holding information that we are going to talk about, right? So let's go with another thing, that is a structure of DNA. Structure of DNA. So like I told you, DNA is a thread-like structure. But if you zoom in, that this DNA will be like this. It's like a spiral case, right? It will be like this, right? And it not only is spiral, it will have staircases built in. Got the point? So this is how this spiral cases are there. If I unfold it, because this look like a spiral cases, but I just want to unfold it. If I make it like this, so this will look like this, right? Isn't it? It will look like this. Although this is a real model, this is a real one. And if I even make it bigger, then it is going to look like this. It is going to look like this. And there would be adenine, double bond thymine. There would be thymine, double bond adenine. There would be guanine, triple bond cytosine. There would be cytosine, triple bond guanine. There could be repetition also. And all the informations are written in that format, right? Right. It is written in that format, right? There is no particular combination of it, but just you need to understand one thing. The DNA is a biomolecule, it is a complex molecule, but here DNA has got the information written in the form of 4 letters, and the 4 letters are, the 4 letters by which information are written is adenine, guanine, cytosine, and thymine. Right? AGCT. One more thing you need to understand, A will always combine with T and C will always combine with G. It's like English language. Like English language has 26 alphabet, this language has 4 alphabets. And 4 alphabets, they make pair, only 2 pair. These are called base pair. What we call it? Base pair. Right? It is called nitrogen base pair. What we call it? Because it's a nitrogen compound. So it is nitrogen base pair. This is one base pair, this is another base pair. So you need to draw it first. This is thread-like a structure. This is a real DNA look like. I just untwisted this DNA and ultimately we got this structure. So information on the DNA is written in the form of linear sequence of nitrogenous base coming from up to down. And there are only 4 codes, adenine, guanine, cytosine, thymine, which makes 2 pairs. A and T is one pair, and then G and C is another pair, that is called nitrogenous base pair. Now you have to write it. Make it first. Okay. Here we are not, we don't want to get into the detail of it. We just want to know that if DNA is having information, how this information is written. That visualization should be there. If DNA is having information, how this information is written. Similar thing I have explained over here. I'll cut once again for you. Right. Similar thing is there. You can see this is how the DNA structure is. You can see real structure look like this, but if you untwist it, then GC is making one pair, TA and AT is making another pair. So all the information written in the linear form. Right? Right. Hydrogen bond. Anuradha, that is hydrogen bond, but then it's of no use. The bond between A and T and G and C is called hydrogen bond, but it's of no use. Right? Remember just one thing. Base pair. What we need to understand? Base pair, or we can call it nitrogen base pair. Right? Right. So there are 4 types of, DNA will have 4 types of nitrogen bases. Right? What are those 4 types? Adenine, guanine, cytosine, and thymine. And now 2 nitrogen base pair. 2 nitrogen base pair. And what are those nitrogenous base pair? Adenine, double bond, thymine. And guanine, triple bond, cytosine. So all the information in our body is written in this linear form. Right? This is how it is written. And this information, let's say up to here, like if I say gene, so gene means here to here, the information written is a gene. It's a gene. So gene is a segment of DNA in which the linear form of information is written. What are the characteristics of this information? Like English has got 26 alphabet, this has got only 4 alphabets, right? If English has got multiple words, it has got only 2 words, and all these things are written in linear format. So all you need to understand that you need to visualize that what kind of information. Obviously, these all have meaning. If you are biologist, biotechnologist, you can get to know about the meaning of it. But here we are not to get the meaning of it, right? So that is why I have explained here. The DNA information are written. This information will pass on to the RNA, and RNA will give this information to ribosome. Ribosome will read this information and it will make the protein. Yeah, it's basic in nature. Anuradha, it is basic in nature. You are right. It is certainly basic in nature. So any confusion? All you need to do is to visualize how these things are happening, how these informations are being passed upon. Like I told you, this is DNA, thread-like structure. This is double helical structure. What we call it? Double helix DNA. What we call it? Double helix DNA. And then we have untwisted it. Then when we look into it, zoom into it, it looks like this. 4 types of base, nitrogenous bases. So 4 types of nitrogen bases, and then 2 types of base pairs. Although DNA is an acid, deoxyribonucleic acid, right? But this particular chemical is basic in nature, right? And I'll tell you that basic is more towards life. Life will not be able to withstand in the acidic medium. Okay? So at the end, this is the most important thing. If we have DNA or gene, then this DNA will pass information to messenger RNA. Messenger RNA will pass information to ribosome. Ribosome will make protein. This is called central dogma of biology. I'll show you one more. And let's cut it from here. Right. Same thing. This is called central dogma of biology. What we call it? Central dogma. Dogma means principle of biology. Entire biotechnology is based on that. Yes, Pravina. So here we can see DNA has got this segments and all these nitrogenous base pairs, right? So DNA will pass on this information to RNA. DNA will make RNA. RNA will be just single stranded. DNA is what? Double stranded. RNA is single stranded. That is called transcription. And then this RNA will go to ribosome and protein will form. That is called translation. Sometime it may be possible that RNA will make DNA, and that is called reverse transcription in retrovirus. Where? In retrovirus. You know that retrovirus? So in retrovirus, they have RNA, and that RNA can make DNA at demand. And sometime, here you can see, sometime DNA will make DNA. DNA is making DNA. You can see DNA is making DNA. So when DNA is making its copy, DNA is making its own copy, then it is called replication. Got the point? DNA is making DNA, then it is called replication. I can change over here also for your understanding. I can draw one another diagram. Let's say DNA basically is the gene, then it is making RNA, and RNA is making protein. You can write in that way. This is called transcription. Yes, more you write, more you will get to know about it. This is called translation. Right. Sometime what can happen? RNA can make DNA, and when RNA is making DNA, that is called reverse transcription. And example of reverse transcription is retrovirus. Only retrovirus it can happen. And there is one more thing, that sometime DNA can make its own copy. That is called replication. What we call it? Replication. Replication. Only when the cell is going to divide. Right? So that is your complete central dogma. And protein is protein is very important because it's a building block, and at the same time, the protein is so important that it is taking care of the entire body function because enzymes are made up of protein. Okay, any problem? Any problem with that? Should we go ahead? So this is our second class of basics in biology. And once we have done the basics in biology, then we can start biotechnology now. So last class and this class. The takeaway of the last class was to understand virus. And takeaway of this class is to understand that how DNA is controlling everything. DNA is like CEO of any company. So DNA is like CEO of any company. And for every work, CEO will not go anywhere. Cell is like a big company. It's like big factory. And cell is functioning like a big factory. And this factory is making bikes and car. And there is one CEO of this factory. CEO is very big person. He is there in the secure chamber that is called nucleus. Inside nucleus, CEO is DNA. And CEO is having all the data and information for bike making and car making. Right? Bike making and car making. You got my point? But CEO will never come out of their own cabin to talk to the workers. So CEO, that is DNA, has hired many managers. Managers are messengers. So CEO will give information to managers, and these managers are RNA, and these managers will go and it will inform the ribosome, right? It's informed the ribosome, right? And ribosome is a worker, and this ribosome will do what? This ribosome will make protein. Get the point? So it's the same story kind of thing. You keep it in the form of a story. DNA is CEO having all the information, but not going directly anywhere. What's the point of becoming CEO when we have to go and talk to the factory workers? Obviously, you are CEO, you are Sundar Pichai. So Sundar Pichai has hired many managers under him, and then he assigned a particular job to one manager, another job to another manager. So DNA molecule may make so many RNAs, different types of RNAs. These RNAs are messenger RNAs. And this messenger RNA is carrying this information of CEO to ribosome. Ribosomes are workers who are making these cars and bikes. And this messenger will go to the ribosome and say that, okay, CEO has given this information, look at this, and make the car and bike of its own kind. That is how it happened. So DNA never comes out of the nucleus. RNA is nothing but the messenger which carry the copy of the instruction that DNA gives to the RNA. And ribosome is a worker, and final product of this factory is protein. Yes, Meenakshi, you are right. Why protein is important? Because we all are made up of protein. Each and every body structure in our body is made up of protein only. No protein, no structure. That is how the protein is very, very important. Now I'm open for questions. I'm open for question. If you have to ask any question, I can tell. Right. Yes, one thing, replication can occur only at cell division. So this replication will occur only during cell division. This will occur only when the retrovirus. Otherwise, in our body, DNA to RNA, RNA to protein. Protein is our final product. Why protein is so much important? Because our body structures are made up of protein, and body structures are made up of protein. And one more thing, that all the biocatalysts or enzymes are protein only. Okay. So now we have done with the basic concept. Basic concept is over. And tomorrow when we meet, we can just start into yes, RNA will not have base pair. Like you can see, in RNA there is no base pair, right? DNA is double stranded. So DNA is double helix. Double helix. So when it is double helix, then it will have base pair. Base pairs, right? But RNA is single helix. What is that? Single helix. So single helix means no pair, only base. Only base, no pair. No pair. So pair condition will not be there. Yes, it will have same code. You can see the code is same, CC, it will have same code, but pair will not be there. Ayush, pair will not be there. The biggest difference between DNA and RNA, DNA is double helix, this is single helix. It will have just bases, but not in paired condition. And RNA is not very permanent structure. RNA is something which is temporary structure. So DNA is permanent and stable. We can add one more point. So DNA is stable structure, right? And this is temporary structure. So this is a stable structure because every time you need that. But RNA is not that stable one. Soumya, other than UPSC booklet and class notes, would we require anything else? Yet current affairs, very important. Rather, from tomorrow, when we start our biotechnology classes, because our basic concepts are over now, and you have to review it once. All the thing you have to review. We started our discussion from cell structure here. And then we talked about mitochondria. We never get into the detail of it. Golgi body stores protein, ribosome makes protein, endoplasmic reticulum where ribosome lies onto it. Nucleus is very important. Nucleus has got DNA, messenger RNA and protein form and stored over here. No, Meenakshi, that is why I took 2 classes to make you understand, because these are the very basic thing. Very basic thing. If you have this basic concept clear with you, then what will happen? In a coming time, we won't have any problem. Now, I promise you one thing to all of you. Just go and read the first 2 classes very carefully. If required, watch it again. And then my promise, next 10 classes of biotechnology will be cakewalk for you. Anuradha, triplet and all, let's forget about it. Not required. Triplet is that codes are in triplet form. Amit, you have to cover the current affairs of 1.5 years. Let's say you are going to write the examination in 2026. So from January 2025, the current affairs should be there with you. So 1.5 year current affair, you should take care of it. 1.5 year of current affairs. And I request every one of you that please do get into this 2 classes. Listen again, revise again, make the notes along with me. I just want all of you to make a very nice notes along with me. That is why I keep a lot of board work so that you can also write onto your notebook. Because this class will be gone. At the end of the day, after many months, you will have just notebook of yours. And current affair note also. For current affair, I can suggest you one thing. Newspaper and magazine is very important, but at the same time, I also run one Telegram channel. So Telegram channel is there. That is beyond underscore UPSC. Beyond underscore UPSC. So my name would be there, beyond underscore UPSC by Ritesh Jaiswal. This is Telegram channel and I update on a daily basis about science and technology and environment section, right? And I call it beyond UPSC because sometimes I put motivational thing also. I mean, life should not be just UPSC, it should be beyond UPSC, isn't it? Sometime I put the voice note also in my voice, although I delete it after 48 hours. Now I'm planning to put some videos there so that I can connect our student after the class also, right? So this is our Telegram channel and there you can go and have it with you. And I'm sure that it will be helpful to all of you. right? And you can see, even now we have just, Gaganyaan, lots of updates are going. So we are putting the information about the Gaganyaan also. है ना? So the basic concepts are over. Tomorrow when we meet, then we are going to discuss biotech. Your first biotech chapter, genomics, will start. And we'll talk about it in detail, right? So that is all for today. I'll see you tomorrow at the same time, 4:15, and we'll have 2 hour totally focused and packed class, right? And please be vocal, speak up. Your class is very quiet and nice. Being quiet is very nice, but asking question will make the class interactive, right? And I really want that 2 classes, if you have not seen, please see, please grasp and come tomorrow prepared, and we'll have a nice discussion around it, right? So that is all for today, and I'll see you tomorrow. Till then, take care. Bye bye. It's already, I think, 6:10. So you must be hungry. Go for the snacks and tea or coffee, and then sit back, relax for some time, and then start your evening study. Right. Praveena is saying that I am biotechnology graduate. Good, Praveena. You might have made good sense of it. Right. Anyway, take care.